Hey everyone, so in this video, we are going to talk about everything you need to know in order to do a thermochem calculation. And the basically the things that we're going to talk about here are the formulas, so what your formula options are, what the variables in the formulas represent, as well as their units, and then how we know when to use each of the different formulas. So let's get started. Let me get my pens here. So first off, we need to know the formulas. Without knowing that, it's not going to be very helpful. And I will probably give you the formulas, but being able to recognize them is important. So let's write those down. So we have the MCAT equation, Q equals MC delta T. We have Q equals MHF, which is the heat of fusion, and then Q equals MHV, which is the heat of vaporization. Now, I'm going to give you guys these equations for a quiz or a test. So just knowing the formulas isn't going to be enough. You need to know what those letters in the formula represent. And that's sometimes half the battle. So let's go through and identify those. Starting with Q, Q is in all three of the formulas, and it does mean the same thing in each. Q represents heat or energy. Remember, for our purposes right now, heat and energy are synonymous. N-E-R-G-Y. And so anytime you see the words energy or heat, we know that it's going to be our Q. And then the units for Q are joules, which is a capital J. The next variable that we have there is mass, M. So M stands for the mass. And the units for mass, hopefully you know, are grams. Now, from this point, the formulas get unique. So we're going to start with the constants. So C is a constant, and I'm just going to list constants down here, and I'll get to that in just a second. But C, HF, and HV are all constants. What that means is you will 99% of the time be given these values either on the piece of paper that you're doing or on the board. Somewhere these values have to be given to you. You are not responsible for memorizing them. And if they're not given, then you can Google. So given or Google. The only time you won't Google or, be given it is if it's looking for it. So if it says, what is the heat of fusion of, this sample, or what is the specific heat capacity of this random thing? Well, then you'll calculate it. But if you need to find it, then, you should be given to it. So HB. So it's just a little side note there. So C stands for specific heat capacity. And the units are joules per gram degree Celsius. Those parentheses are kind of wonky. Sorry about that. So joules per gram degree Celsius. HF is the heat of fusion. And we do need to be able to recognize the heat of fusion of water for this class. So the heat of fusion of water, in our case, heat of fusion is 4 joules per gram. And so there you can see the units for the heat of fusion as well. And then finally, we have the heat of vaporization. Oh, that's annoying to write. And the value for water is 2260 joules per gram. Again, these numbers are going to be given, but you need to know which is which. So I'm just going to give you 334 joules per gram and 2260 joules per gram. You have to know which is the heat of fusion, which is the heat of vaporization. And then the only thing here now that we haven't talked about is the delta T. And the delta T represents the change in temperature. And this is really important because it's not always going to say the temperature change was this many degrees. A lot of times it's going to be like, oh, we started at this temperature and we ended at this temperature. So we have to know how to calculate the delta T. And to calculate it, it's always the final minus the initial. And that's going to give us our, our change. And the sign is in, oops, that's a C, not a T. Let me get my white out here. That's my bad. I'm sorry. Okay, here we go. So the sign is important. A positive sign means that, so if we have a positive temperature change, it means that we gained energy. And if we have a negative sign, it means that we lost energy. And that's going to go back to our Q's as well. So that's important to know. Okay, so I think that that's it in terms of the variables and the formulas themselves. So now we need to ask ourselves, okay, now that I know all this stuff, which one do I use and when do I use it? So if I'm reading a problem, when do I use this formula, that formula, etc. So I'm just going to split up the 3. Line. There we go. Okay, so we have 3 sections because we have 3 separate equations. So, and I'm going to extend this down. Okay, I'm just going to put this guy in a little box because this is like a side note. Go that way. Okay, sorry. I'm distracted. So, when do we use each of these? We are going to use Q equals MC delta T anytime there is a temperature change. If I'm reading the question and it says the temperature is changing, or it gives me a temperature change, or it's asking me to find a temperature, then I am going to be using this equation. So temperature change, 100%. These 2 formulas then are going to be during a phase change. But we have 2 different formulas because they're each for a different phase change. So MHF is going to be for those lower temperature phase changes, meaning we're going from a liquid to a solid to a solid, or a solid to a liquid, which we call freezing or boiling. Oops, there you go. And then this one, Q equals MHV, that's going to be the phase change that's at the higher temperatures. That's going to be going I'm going to make that a G, from a gas to a liquid, or vice versa. And we call that evaporating or condensing. So in order to answer a calculation question, this is the information that you need to know. If you know this stuff, then you just got to plug in the units. So check out the next video if you need some help with, the actual calculations. But this video is giving you all the tools necessary in order to make those calculations happen. Thank you.